Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast we call Space Nuts. My name's Andrew Dunkley, and my fellow partner in crime also shares the packet of nuts with me because we can't afford more than one, is Fred Watson. Hello, Fred.
We've got to get some new nuts.
Yes.
How are you, Andrew?
I am well. It's raining here. We are so thrilled.
Yes, doing the same here.
For those who do not know, we are getting a visit by a royal couple next week. The Duke and Duchess of Sussex will be visiting good old Dub Vegas on their Australian tour. They're here for the Invictus Games, but Harry and Meghan have included Dubbo in their round of visits because of the drought, because this is drought central at the moment, and now it's raining. So we're going to have a bit of a green drought for them, I imagine, but that's fine. It doesn't change anything, and one day of rain isn't going to break the drought. But yeah, we're thrilled to have them, and people have put cardboard cutouts of them up on the balconies of pubs and all sorts of stuff. It's really good. We're having a lot of fun with it. Fred, today we're going to talk about a new dwarf planet that has been discovered. They've called it Goblin. I don't think that'll stick for some reason. World Space Week. And a question from Deke Harrison about the Big Bang and what we can see and time and all that sort of jazz roll into one. We'll get to your question a little later, Deke. Thanks for sending it in. Before we start, you've just come back from Starfest, which is a fairly local event in our calendar, isn't it?
Indeed, that's right. So, yes, it was a busy week in Coonabarabran last week. Two big events. One was a conference called Riding the Light Wave of Technology, which Marnie masterminded and organised and brought together totally disparate groups of people to talk about Alan. And Alan's not a person. Alan is artificial light at night. And so it interests astronomers, of course, because light pollution is an issue for them. And that's the angle that I came at it from 20 years ago. But now the Alan issue has become much more widespread. And we're kind of starting to realize that artificial light at night, particularly light with a high blue content, tinkers around with our well-being in a way that we hadn't previously realized. And so there was a big, strong medical contingent in this conference, as well as a lot of people talking about flora and fauna and the deleterious effect of outdoor lighting on them. So a great meeting with some good outcomes. And then we went straight into Starfest, the annual open day for the observatory, and a few other events like Science in the Pub and the Bok Lecture, famous, making Coonabarabran famous every October. The climax of the whole weekend was the opening, the formal launch of the Warrumbungle Dark Sky Park, which you might remember we had recognised as Australia's first international dark sky park back in 2016. It's taken a little while to get it formally launched, but that happened on Saturday. We had the Chief Scientist and Engineer of New South Wales, Hugh Durant-White, came and did the honours, and we had a lovely evening launch in the Warrumbungle National Park under the stars, and it was a brilliantly clear night, and it couldn't really have gone better, Andrew. So fantastic. We missed you.
Yeah, look, I've been once or twice over the years, and we've had the Bok Lecture in Dubbo quite a few times, although that seems to have fallen by the wayside in recent years. But I've hosted that a couple of times and met some astounding people doing some amazing things in astronomy. So it is a fabulous event, and it's good that it's happening every year, because I think people want to know. People just so full of questions, as you and I are aware of, with the number that come into us about life, the universe and everything. If they just believed the answer was 42, we wouldn't have anything to talk about. And one thing we are going to talk about this morning is the discovery of the new dwarf planet, Goblin. Now, it's not a new planet because it's probably been there for a long time, but it's newly discovered.
It's newly discovered. And to come clean, its proper name is 2015 TG387.
I like Goblin better. Only slightly
Goblin.
better.
Yeah. So why is it called a goblin? Well, it was discovered, as its name implies, in 2015. And that discovery was made round about Halloween. And people were obviously thinking Halloween-y thoughts. And they liked TG as well. TG suddenly became the Goblin. And so the Goblin is what its name is now. But as you said a minute or two ago, you can bet your life that when it finally comes to the crunch of choosing a name for this object, it will not be the Goblin. What is it? Okay, it's a dwarf planet. That means it's spherical. It's about 300 kilometers across. But what's interesting about it is not its shape or its size. It's where it is, because it's in the really dim and distant outer reaches of our solar system. Its orbit is very, very elongated. It's so elongated, it's almost a straight line. When it is at its closest, it's about 2.5 times further from the sun than Pluto is. Pluto's about 6 billion kilometers on average. So 2.5 times further. But at its furthest, it's 60 times further than Pluto. So, you're talking not quite 1 trillion kilometers. It's about, I think I worked out, it's about 360 billion kilometers when it's at its furthest. And its orbit, its year, wait for this, its year is 40,000 years for one trip around the sun. So it's a slow-moving, distant, remote, tiny object. And very faint, because 300 kilometers across is not much when you're looking at those sorts of distances. And so there's a really nice comment here that says for 99% of its orbit, it will be too faint to see. That's on the Guardian website.
I'll tell you one positive thing about it. If you ask for a Maserati for your birthday, they'd have plenty of time to save up and get it for you.
I don't know whether they have Maseratis on the Goblin.
Oh, they've got to.
They've probably just got Mitsubishis like I do. So the story that's all the facts as we know them, but the backstory is the interesting bit, because this plays directly into something that you and I have spoken about many times before, and that is the hypothetical Planet 9.
I was going to bring that up, and I was going to ask you, could this be?
It's not Planet 9, but it's telling the same story as the other asteroids out there in the outer solar system. And in fact, it was because of the search for Planet 9 that this thing was found. So just to recap, this sort of, I suppose, belt of icy asteroids way out in the depths of the solar system. We call it the Kuiper Belt, although sometimes that's a misnomer. The safest way is to refer to them as trans-Neptunian objects. These are objects beyond the orbit of Neptune, because there are several different categories of them. But the Kuiper Belt is one of them. That's a belt of objects that was predicted actually back in the 1950s by Gerard P. Kuiper, who was a very well-known Dutch-American astronomer. He suggested that the leftover debris from the formation of the planets is orbiting way out in the depths of the solar system. And sure enough, in 1992, I think the first one was found. We now know that Pluto is one of these objects, and there are many others as well, including at least one that's bigger than Pluto. So that's the family of objects that the Goblin belongs to. But what you and I have already talked about is that some of these asteroids are in very elongated orbits, like the Goblin, and their orbits are all sort of aligned in the same direction. And that has led astronomers to believe that there is a much more massive object way beyond even the Goblin, which has gravitational pull, which is aligning these orbits, and it's an object that is as yet undiscovered.
Planet 9?
Planet 9, that's right. So Planet 9 is what that's being called. It was hypothesized, it's about 3 years ago, I think, when it first, the idea first came up. And so since then, people have been looking for it. And as part of the search for it, what's happened is they found the Goblin, which is another dwarf planet. It's not Planet 9, but it's certainly in the same sort of direction. I think Planet 9 is thought to have up to 10 times the mass of the Earth. So it's a big object, but it's also thought to be at an extremely remote distance, which is why we haven't found it yet. And the interesting aspect of all this is that the place where people think Planet 9 is hiding is right in the Milky Way. So you've got an area of sky that is absolutely spangled with stars. And what you're trying to find is a very slow-moving star moving among them. In other words, something that's just like all the others, because at that distance, Planet 9 would just look like a star, but that is moving slowly between the stars. And that's quite a difficult problem if you've got very rich or very dense fields of stars.
So we can't see the forest for the tree, basically. And,
exactly, that's right.
Is it possible that this Planet 9 could be one of those rogue planets that you and I talked about once, that just sort of gets thrown out of whatever orbit it was in, wherever it was, and is just floating around?
It's possible, that's right. That would mean it was not gravitationally bound to the solar system. And I think the calculations that people have done to sort of predict where Planet 9 is, and this is all based on the elongation of these asteroid orbits, I think that has it near enough that it is gravitationally bound to the sun. So it is actually in orbit around the sun. Probably, with a similar kind of 40 or 100,000 year orbit, something similar to what we're talking about with the Goblin. It's interesting stuff. And one of the things that makes you take this seriously is that the Goblin was discovered by one of the biggest telescopes in the world, the Japanese Subaru telescope, which is on Mauna Kea, the best northern hemisphere site in the world for putting optical telescopes. It's an 8-meter mirror, and that means it can see very faint objects. But Subaru is interesting because it's got quite a wide field of view, so it can produce images of relatively large areas of sky. Most big telescopes, you only see a very narrow field of view, and the Hubble is the extreme example of that. It looks at tiny bits of sky in great detail, whereas what you want to do is look in detail, but also see a big area of sky, and the Subaru telescope lets you do that. So clearly the time allocation committees that look at dishing out telescope time take this proposal for Planet 9 very seriously indeed, and are giving big telescope time to the project to try and find it. Yes. So it's a question of watch this space. When the dust settles a bit, I'm sure the Goblin will get a much more elegant name. These trans-Neptunian objects typically are named after figures in the creation legends of the indigenous people in the territory in which the object was discovered. So no doubt the Goblin will wind up with a very elegant Hawaiian name, because that's where it was discovered.
Fantastic. And while we're still out there, I've heard whispers that there's another campaign going on to have Pluto reclassified as a planet. Yep. But if there's another object in that area that's bigger than Pluto, then you'd have to make it a planet too, and then you start to get into real messy stuff.
Yeah. I think most astronomers in the world share the same view that I have. Pluto is not a planet, and it never was. End of story. We just misclassified it.
Well, it's the only one we found in 1930, so
that's right.
Now that we've found it, a whole bunch, it starts to make
there's more than
sense.
1,000, more than 1,000 of these objects known already, and there are probably millions out there. So it's not a planet.
Okay.
But that, it's still one of the most interesting objects in the solar system, and as we know from the flyby of New Horizons back in 2015.
Yes, indeed. All right. We will keep an eye on things, and hopefully in the not-too-distant future be able to tell you about the discovery of Planet 9. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, a global topic. We don't get to talk about global topics too often, but this one is World Space Week, which by the time people have downloaded and listened to our podcast will be well underway. This is a United Nations event, and it was first declared in 1999. A very good year, as I recall, for Australian sport anyway. So, World Space Week, what's happening? What are you doing?
Well, I've done my bit already.
Yes, well, you have with Starfest, of course.
Yeah, well, no, there's a bit more to it than that, and I'll talk about that in a second. But let's introduce World Space Week. It is a major event, as you said, been going since 1999. They are expecting to have something like 4,000 events in 80 or 90 countries. The theme for World Space Week this week is for 2018 is Space Unites the World, which I'm very supportive of. Space Week runs from the 4th to the 10th of October every year. So it doesn't sort of run from Monday to Sunday or anything like that. It's always
the dates are set in stone.
They are because October, any bells?
No.
No, you don't remember 1957, Andrew.
I was probably not around then much.
Yeah, I remember it. That was the launch of Sputnik. Sputnik 1.
The penny just dropped.
Yeah, the first artificial satellite and launched by the Soviet Union on the 4th of October, 1957. I remember it well.
Mm-hmm.
So an extraordinary event, and that has now become the opening day of World Space Week.
See, I should have remembered it because I actually read a little bit about it on the radio the other day.
Okay.
About the launch of Sputnik, so it should have been at the front of my mind, but my mind tends to, once I've read something, that's it, I don't have to remember it anymore. Which I don't think is what reading's for, but anyway.
Well, no, that's what writing's for, actually.
Yes.
You write it down so you don't have to remember it. A little bit more about World Space Week. It's, and I'm reading from the website here, it's an international celebration of the contribution of space science and technology to the betterment of the human condition. World Space Week consists of a myriad of space-related events held by space agencies, aerospace companies, schools, planetaria, museums and astronomy clubs, and space nuts in a common time frame to achieve greater student and public impact through synchronization. So it's a pretty big event. And of course, for us this year, us in Australia this year, Andrew, it's got additional significance because now we have our own space agency. The Australian Space Agency can participate in World Space Week. And that's kind of how I got roped in because day before yesterday, I recorded a whole lot of video clips, I guess, little snippets in our parent department, or the organisation I work for, the Department of Industry, Innovation and Science, part of the Commonwealth Government. These are going to be the little quirky space facts. A bit like the stock in trade of space nuts. And all I did was sort of, spewed out a space fact for this recording, one a day for World Space Week and then one a week for the rest of the year. And
I've had a quick listen. The first one, for anybody who's interested, goes, space is really big. It's so big. No, hang on, that's something else.
Yeah. Well, I always loved, it was Douglas Adams who said, space is big, really big. You might think it's a long way down the road to the chemists, but that's nothing
compared to space.
He had a way with words, that guy.
It was brilliant.
So these things, I haven't actually checked this out, so I don't know whether it will work or not, but apparently they are on the Twitter handle at ScienceGovAU. So all one word, at ScienceGovAU. I'm going to have a look for them after you and I have spoken to see whether they came out. But they're some of the quirkier little facts that you and I delight in about space and about astronomy. Just very briefly, it's a very brief thing. I don't know how it will turn out. It was all done on Monday morning this week, but we had a good time doing it. So
realistically, having a week dedicated to space is probably a good thing, given what we don't know about space and what we're trying to learn about space, and finding things like Planet 9 and learning about where we are in the universe and why things are happening the way they are. And the fact that we get absolutely bombarded with questions. I mean, our email systems look like the surface of the moon because of all the emails that come in and pockmark our inbox. But the reality is there are so many millions of people that want to know what's going on out there. So having a dedicated United Nations week towards answering some of those questions or celebrating space, I think it's a fabulous idea. One of the things that's happening locally, I mean, we talked about Starfest, but this Saturday night in a little town called Wellington, just down the road from us, they're having a telescope night at the Wellington Caves. There's a big cave complex there. It's a tourist attraction. They've brought a fellow up to talk about space from the Aboriginal perspective, about some of the stories of the Aboriginal interpretation of space. So that should be a really fun night on Saturday night. It's the last opportunity to see something at night because we switched to daylight saving after that. So they're doing it at the last possible moment.
Very good.
Should be a lot of fun.
Sounds great. And of course, there is a rich, really rich literature, if I can put it that way, of Aboriginal Dreamtime stories and legends, many of which actually relate really well to events in the sky. There are Dreamtime stories that have now been proved to be about asteroids that have hit the Earth and things of that sort. It's really remarkable stuff.
It is indeed. And if anybody wants to go to the website for World Space Week, it's worldspaceweek.org, which should be fairly easy to remember. I'm going to write it down.
Yes, I'll need to as well.
Celebrate World Space Week with us and everybody else around the world. This is Space Nuts. Andrew Dunkley here with Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, a question. This comes from Deke Harrison. Thank you, Deke. We appreciate the question. We're going to do this in two halves because he's asked a lot of questions because he's been listening to back episodes of Space Nuts, and it's prompted a lot of questions in his mind, and that's fair enough. I understand that the further out we look into the universe, the further back in time we are looking, which in itself is crazy. I'm curious to know if it is within the realms of possibility that somehow, maybe with new technological advances, we will directly observe the Big Bang or light of the Big Bang as it happened. Would this maybe provide the missing link between general relativity and quantum theory?
That's a great question, Deke. And I agree with you that looking back in time is crazy, but it's just a property of physics. It's a bit weird because, so yes, we from our vantage point, as we look out into space, the further we look, the further back in time we're looking because of the finite travel time or the finite speed of light, 300,000 kilometers per second. So if you could look out 300,000 kilometers, which is not quite the distance of the moon, you'd be looking back a second and all the rest of it. And eventually you're looking back billions of years because you're looking so far back. The interesting thing, though, is that we can never see the universe in any other way because you've always got this ultimate speed limit. So while it's a crazy thought, what it means is that we sort of have to envisage the universe in this peculiar way that the further away you look, the further back in time you're seeing, because there's never any way of seeing things as they are now, if I can put it that way. So that does make it really slightly odd.
No, I get it, because it's a simple case of what you see is what happened in the time it took for the light to reach us, and what's happening there now we won't know about until that light reaches us many thousand or 100,000 or millions of years or billions of years' time. So it's always running at the same speed relative to the size of the universe, and therefore we can never catch up. It's like watching something on record 10 minutes behind what's on air live, and you never catch up while you're watching in real time. So if we had a fast forward button on the universe, yes, but we do not have that.
Yeah, that fast forward button would need things to travel at faster than the speed of light.
Exactly.
And nothing travels faster than the speed of light, not even light. Okay, so that is sort of leads into the second part of this question. Deep wants to know whether it's within the realms of possibility that maybe with new technological advances we'll directly observe the Big Bang or the light of the Big Bang as it happened. Now, Deep probably already is aware that we can look so far back in time that we are actually still seeing the flash of the Big Bang. And it's not the Big Bang as it happened, though. It's the aftermath of the Big Bang. For the first 380,000 years of its existence, the universe was a brilliant fireball, glowing, intensely brightly. But what that means is that because it was so bright, you couldn't see through it. It was like living in this fog of brilliance. So light didn't actually move through the universe. It was just light that was there already.
I've always found it very difficult living in a fog of brilliance. It's a lonely life.
Well, you'd know. That's right. You would know. A fog of brilliance, not intellectual brilliance, just physical brilliance. All right.
Okay.
I think most of us have probably.
I wasn't brilliant enough to figure that out.
Most of us have probably driven a car through fog, where the headlights, all they do is light up the fog, and that's all you can see. You can't see what's on the, what you're trying to find. So the universe was like that. It was just a brilliant fog of light. And then it cleared relatively quickly after about 380,000 years. And it's because of the fact that it cleared everywhere at the same time that we can still see it. So ever since then, the universe has effectively been transparent. But if we look far enough back in time, we can see that time when the universe was still a fog. And we see it as a microwave signal across the whole sky. It's called the cosmic microwave background radiation. Why isn't it a glowing white light? It's because the universe has expanded by a factor of more than 1,000 since that light was emitted. So the expansion stretches the light waves and they become radio waves. That's the bottom line. And so we can still see that. But Deke's point is well made, because at the moment, all we can see back to is 380,000 years after the Big Bang. And we can't penetrate that any further. So the cosmic microwave background radiation is like a wall. It's kind of artificial, but it is a wall beyond which we can't see. So we can't look with light or radio or X-rays or any of the electromagnetic radiations further than that time. In other words, we can't look back beyond the 380,000 year point. So it's physics that stops you doing that. So you've got to look for other things, and there are, as Deek suggests, new technological advances that might let us penetrate that horizon that we can't see beyond. Two of them come to mind. One is subatomic particles, and we know that when the Big Bang happened, it was rich in neutrinos. So there was an intense bombardment of neutrinos from the Big Bang, which subatomic particles, they pass through the Earth with no problems at all. We don't yet have neutrino telescopes that can sort of map, what the physics of where they came from and things of that sort. But those neutrinos, perhaps in a fairly speculative sense at the moment, but they do suggest that there might be ways in which we can cross this cosmic horizon. We can actually see the neutrinos being emitted by the Big Bang itself. We haven't got there yet, but it's a possibility. And another possibility, which is similarly speculative, is gravitational waves, because we've now built instruments that can detect colliding neutron stars and colliding black holes by the ripples that they actually set up in space itself. The Big Bang was the ultimate, Big Bang within the universe. So there would almost certainly be ripples in space-time from that. We can't detect them at the moment, but maybe, just maybe, down the track, we might be able to build interferometers, as they're called, that are sensitive enough to detect that. So there is possible technology that might take us further forward with that. Okay. So that kind of answers part one of Deek's question. Part two is even more speculative. Go for it, Andrew.
Okay. Could this be why we haven't seen intelligent life yet? Because as soon as life in the universe becomes intelligent enough to observe the Big Bang, this creates some sort of cataclysmic disaster where the universe resets. Interesting. So many possibilities are going around in my head, and I can't be the only one thinking about this. Interesting thoughts. What do you reckon?
It is an interesting thought. And it's, it sounds kind of unexpected that you might link the existence of intelligent life to physical phenomena going on in the universe. But it's not quite as far-fetched as it sounds. Excuse me, Andrew. One of the curious things about quantum theory, which Deek has already mentioned, is that things change when you observe them in quantum theory. Particles that are very small can exist in what we call a state of superposition, which means that they can be in more than one place at once. They can be in more than one state at once until you look at them. And then they suddenly they drop into a state where they behave like perfectly normal particles.
You and I talked about this not so long ago, and I read an article that suggested what sounded like a pretty outrageous theory, that we live in a world that we create in our own minds.
Yeah, it's that sort of thing. That's right. It's almost like that. This is quantum theory is a little bit more, perhaps I can put it this way, physical than to suggest that it's stuff going on in our minds. And in fact, with quantum theory, the normal interpretation is that when things are in this funny quantum state where they can be in more than one place at once, they're completely isolated from their surroundings. And so looking at them, which means photons transmitting from one place to another, actually connects them with their surroundings, and they lose that quantum weirdness. But there are theories that extend that to almost the kind of thing that Deek is talking about, that you need consciousness for things to behave in a certain way. It's a very in many ways, as I said, it's speculative. It's just one of the ideas behind the way the universe works, this sort of bizarre connection between the physical universe and a consciousness that can appreciate it. And it sort of suggests that if you don't have intelligent life in the universe, there is no universe. But that that's a really long shot to draw. So the answer is we really don't know enough about this. I think most physicists would dismiss it as being irrelevant, and they say, well, if there's no intelligent life in the universe just carries on and doesn't give a hoot, that there's nothing there to look at it or understand it.
If a tree falls in the forest.
That's right. Do you know about it if you're not there? So it's... even Einstein pondered the theory: is the moon still there when nobody's looking at it?
Yes, that's right.
So it does have. It's not a random thought, and as Deke said, you're not the only one thinking about this. There are people who put a lot of pretty intelligent thought into it. Generally, I guess what it's possible to say is that this strays into the world of philosophy rather than physics. And philosophy and physics coexist pretty well together. And I think each can teach the other stuff about the realities of the real world. We've got all sorts of ideas that pop out of this. Relativity itself suggests that all time exists already, that it's there and we just kind of progress through it, and that the passage of time is just an illusion. And so how does that feed into the mix? If all of time exists, what part does intelligent existence play in that? So these are rambles, very, very bizarre rambles, but I think it's encouraging that people like Deke are thinking along these lines, because some of the great thinkers of the world have gone down this path too. And I think maybe we might find more concrete answers, not in the near future, but I think it is in the destiny of our species to understand this sort of stuff a lot more.
Indeed. Deke, thank you so much.
Yeah, good question.
Great question. Also answered a question for me as to why golf is so hard, because you have to think about it, and they advise you not to when you're trying to play the game, and therefore they can't coexist. That's what makes the game so difficult. Thank you, Fred. Thank you very much. It's been a lot of fun this week.
Great to talk to you.
It's never been fun before, but it's been a lot of fun this week.
No, it's always rubbish before. No, great stuff, and good to speak, and I hope we'll speak again next week.
I hope so too. Fred Watson, astronomer, and don't forget to look up his little space facts videos on Twitter at ScienceGovAU, G-O-V-A-U, ScienceGovAU on Twitter. And for World Space Week, go to the website worldspaceweek.org to get involved if you can locally in regard to whatever might be happening in your area. And yes, we will be back next week with another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.